Yeah, good morning all. Myself I Himmat Kumar from Civil Engineering Department. So next we are going to our third topic in CO2. That is nothing but the vertical reinforcement. If the forces are applied to a deep beam in such a way that hanging action is required, bars or suspension stirrups shall be provided to carry all the forces that are concerned. Next one is the side face reinforcement. Side face reinforcement shall comply with requirements of minimum reinforcement of walls, and you can see in the first figure you can observe the crack. It is observed at 45 degrees where it is a web shear progress along dotted lines. Next, if you see the second one, that is the flexural strength, flexural tension. So when the steel is getting to yield, you will be getting the crack. And next one, third one, if you see the flexural compression, you can see the larger crack which is coming from the topmost portion to the bottom portion. So these are the different failure modes. First one is the web shear progress along the dotted line, and second one is the flexural tension where the steel yields, and next one is the flexural compression. So when concrete crushes in compression, these are different failure modes. And you can see this is nothing but the stress behavior. So you can see here first it is a curved line, later it is a straight line. So first here it is, in the case of first one, first phase, that is the actual distribution, and second one is if you take it, that is nothing but the average distribution in the case of the rectangular beam. So here this is the stress profile in the case of a rectangular beam. Next one, if you can see what are the classes as per IS 456. So design shear strength of concrete tau C. You can see here depending upon that is nothing but 100 AST by BD. So for M15 grade concrete, for M20, M25, M30, M35 and above. So it is ranging from 0.28 to 1.1. So the 100 by BST ratio should be less than or equal to starting from 0.15 to 3. So you can see here starting from M15, M20, M25, M30, M35 and M40. So here the main thing we have to keep in mind is the term AST is the area of longitudinal tensional reinforcement which continues at least one effective depth beyond the section being considered except at support, where the full area of tension reinforcement may be used provided the detailing conforms to table number 26.2.2 and 26.2.3. So this is about the design shear strength of concrete tau C as per IS 456. Next one is, you can see as per IS 456 what is the maximum shear stress, that is nothing but tau C max. So for M15 grade of concrete, tau C max can be taken as 2.5 Newton per mm square. For M20 grade of concrete can be taken as 2.8 Newton per mm square. For M25 grade of concrete can be taken as 3.1 Newton per mm square. For M30 grade of concrete, it can be tau C value can be taken as 3.5 Newton per mm square. For M35, it can be taken as 3.7 Newton per mm square. For M40 and above up to M60 or SM70, the value can be taken as 4 Newton per mm square. So this is the maximum shear stress, maximum shear stress tau C max we have to consider while going for designing as per IS 456. So for that one, just we can see one example like how the question is given and all. So design of simply support deep beam. So here we are asked to determine the thickness and reinforcement for a simply supported transfer girder of length 5.2 meter loaded for 2 columns at 1.75 meter from each end with 3750 kilonewton. So the total depth of the beam is taken as 4.2 meter and the width of the supports is taken as 520 mm. So assume the grade of concrete is 40 and the steel is Fe415. So automatically, as we are taking a grade of concrete, tau C max we should take it as 4 Newton per mm square, which we have seen in the last figure, and you can see here the length, the gutter it is laying 1.75 meter. Okay, next one is the 1.490 meter from the mid portion, and you can see the cross section of the steel. Okay, and also the depth of the beam, that is nothing but 4.2 meter. Again, that is divided into 3800 as well as 4400. So the solution of this problem we will be seeing in the next topic. So quickly, just I am what say winding up the things. So coming for the what is meant by vertical reinforcement, if the forces are applied to a beam in such a way that hanging action is required, bars or suspension stirrups shall be provided to carry out the forces concerned. And coming for the side face reinforcement, side face reinforcement shall comply with the requirements of minimum reinforcement of walls. And coming for what are the different failure mode pattern, first one is the web shear, that is progressing along the dotted lines. So you can see the crack which is occurred exactly at a 45-degree angle. Next one is the flexural tension. So whenever the steel starts yielding, there you will be getting the crack. Next one is the flexural compression. So when the concrete precision compression, you will be getting the more crack, which we can see the failure pattern in the case of web shear progress, flexural tension as well as the flexural compression. Coming for next one is the stress distribution in the case of rectangular beam. First it will be having the curved line, then after that we will be getting the straight line. So in the case of first one, that is actual distribution, and second one it is having the average distribution, which you can see in the figure, and as well as the reinforcement also it is shown here. And coming for as per IS 456, what are the design shear stress considerations TOC for concrete, ranging from M15, M20, M25, M30, M35, M40 and above. So it is nothing but 100 by AST BD ratio. It should be less than 0.15 to 3 and above. So the values are getting the TOC values we can take starting from 0.28 to 1.01, depending upon the 100 AS by BD value as well as the grade of concrete. It will be varying for individual design. Next, if you take the maximum shear stress TOC max, for M15 grade of concrete it is 2.5, for M20 it is 2.8, for M25 it is 3.1, for M30 it is 3.5, for M35 it is 3.7, for M40 it is 4 Newton per mm square. So here a example problem is given. So there they are asked to find out the this is actual design of a simply support D beam. So here you are asked to determine the thickness and reinforcement for a simply supported transfer girder of length 5.25 meter, loaded for 2 columns at 1.75 meters each from each end with 3.3750 kilonewton. You can see that clearly in the figure. Next, the total depth of the beam is taken as 4.2 meters and the width of support is taken as 520 mm. So you are asked to assume grade of concrete for M40 and grade of steel is Fe415. So whenever grade of concrete is taken as 40, so TOC max should be taken it as 4 Newton per mm square. Okay, the problem and all we will be seeing in the next session. Thank you all.